Hi, welcome to this video where I'll be explaining the 2023 HSC Extension 2 paper, question 16C, which was notoriously difficult that it made the Sydney Morning Herald news. And the student Vivian from Bruce gave her solution, and this video is my take on it. Okay, so we have this question where we have complex numbers w and z that lie on the unit circle. That's modulus 1. And they are separated by an obtuse angle. That's what this part means. Okay, so I can just plonk down z somewhere over here, let's say, and make sure that w is more than pi on 2 apart from z. Okay, and it's just an obtuse angle away. So this angle here is going to be arg of z over w. Okay, so at this point I'm going to let theta equal to the principal argument of z just to clean up some algebra later on. So this angle here is theta, and at this point I'm going to also extend z backwards to negative z here, and also w to negative w here, and z to let's make that pi on 2, it's perpendicular to iz over here. And now it will become apparent why I'm doing that very soon. So let's now unpack this expression here, the xz plus yw. So what does that really mean? Well, for any real number x and y, we are taking linear combinations of z and w. So essentially, this is the entire complex plane. So this actually represents any point in C as a linear combination of z and w. So what does that mean? So let's take any arbitrary point, let's say over down here. How do we get there using only z and w vectors? So we can actually go this way back, this much parallel to z, and then this much parallel to w. Okay, so at university they'll call these vectors the basis vectors because they're not parallel, or the proper term is linearly independent, and they also span the entire complex plane, the entire space. Okay, so let's do another example. Let's say at this point here, how do you get to that point? Well, you just take this much z and then this much w to get there. Point being, it is any point in C. So then the bottom part, the denominator, what does that mean? The denominator means a rotation, right? How much do we rotate by? Rotate this number we got on the top, right? Any point in C, rotate it. The number, or the vector, so the vector, theta clockwise. Okay, so it's just a rotation by theta clockwise. So theta is the argument of z, of course. And so that brings us to this diagram where I've drawn iz and negative z. So if you think about it, this angle here, this angle for iz, if you rotate it theta, you actually get to this line here, right? So this angle here is actually theta as well. And then this angle here is also theta, right? So essentially, I will need any point in this zone, I'm just going to call it the zone, extended radially outwards, any number in this zone, rotated an angle of theta clockwise, will always end up in the second quadrant. Okay, so that's what I'm considering for this next part here, right? So the argument of xz plus yw, remember that means any point on the complex plane, rotate it theta clockwise, it needs to be in the second quadrant, pi on 2 to pi, right? So if you rotate angles, vectors along this line, theta, you'll end up on this axis. If you rotate any angles here, vectors here, you always end up onto this one. So anything in between will end up in the second quadrant. So that's the main setup of the question. So now, how do we actually get the values of x and y's, right? So how much z do I want so that I'm in this region? So you can see from this picture, you can't have positive values of x, right? You can't go this way to get into this region, right? So you're basically running away from that region if you go this way. So you know for a fact you have to take negative scalar multiples of z, right? And then you also are allowed to take scalar multiples of w, but also has to be backwards as well. It also has to be negative, because you go along here and then you go parallel to w, well, you're out of the zone, right? That's not in the zone. We need to make it into this zone. So how do we actually find out what the values of x are? Well, just to summarize what I just said there, right? We know that the values of x has to be negative. Right? We need to have negative scalars of z to get into this green zone. Okay. So once you have decided, well, how much x do you want? So let's say, let's use a different color. Let's say we have traveled this much z, right, backwards. I'm going to call this this length, let's say capital A, or I mean just absolute value A. So there comes a point when if you go parallel to W, right, you're still in the zone, but then you get out of the zone if you go too far. So how far is too far is the question. So the question is, how long, what's the maximum length of this guy? So let's call that absolute value of B. I'm going to try and find a length of this B, given this value A. Okay, so this is where the geometry comes in. So I know for a fact that this angle here is arg of z on W. And, well, you go and do some, what's that, year 7 geometry with parallel lines. This angle here is going to be pi minus arg of z on W. And so therefore, this angle here is also the same. This is pi minus arg of z on W. Okay, so it's a bit messy there. But essentially, this angle here is arg of pi or minus arg of z on W. So this is the fun part, how to find the length of B. So let's bring it down here. Well, I know that cosine of pi minus arg of z on W, doing some year 9 trigonometry, is the length of A divided by the length of B. So let's just clean this up a little bit. Cosine pi minus, well, that's just negative cos arg of z on W. And we get this guy. Okay, so, and then let's just do some algebra to clean it up even further. We get this value. So remember, this is the value of x, right? This is an x value. And it is negative, right? As I've said before, it has to be negative. And this b, well, b is also negative, right? Because you're taking, well, it's pointing in different directions. So putting that together, I don't know why I use A and B, so I'm going to just go, well, B was really Y, and A is really X, right? I don't know, yeah. So then we go and use all these facts, we get this relation. Okay. So maybe I like Y to be the subject, so I'm going to make that negative X over cosine of arg z on W. Okay, so what does that tell us? Well, that's the maximum. This is the max length of Y given X. Okay, so let's now draw our sketch of what X and Y can possibly be. So now I've already said that X has to be negative, okay? Right, so we know it's in this part of the number plane, it's on the left side. And Y value has to also be negative, right? It has to point backwards, but it can't point too far back. So I know that it is capped at this line given by what I just calculated. So y is equal to negative x over cos arg of z over w. And of course, you got to remember that this is dotted because we can't be exactly equal to that line to satisfy the inequality. And as I said before, y has to be negative as well. So I'm going to make sure that our region lies in here. And that's our final answer for the question. Okay. And that's it. So let me know if you have any questions. But that's the solution. Thank you.